Hello everyone! In this video I'll be explaining the build I use for the enemy. This is intended for beginners to intermediate level to help you get ideas on how to make your own starter enemy. It is not a tutorial but meant as an informational video to show the inner workings of my AI enemy that I built. So you can feel free to pause and fast forward the video to wherever and whenever you want. Part 1. Environmental Awareness. The senses consist of a cone geometry for the vision in the front of the enemy and a sphere for the back. This is what the blueprint looks like for the cone geometry. The player is detected as it overlaps the geometry and switches the behavior tree from idle to combat. Here's an example of what happens when the player leaves the geometry.
The AI moves to the last location.
As the player overlaps the geometry, the vector for the last location of the player is saved into the player last location node in the blackboard. This box trace emits a four-sided rectangle from the character capsule to a limited set distance on the x-axis. I broke the hit and used the hit actor to drive the change in behavior from its current state to combat. I used the visual feedback to show the player the different AI behavioral state. The exclamation mark changes color to represent the different behavior states. Yellow for caution, orange for alert, and red for combat. Here's a quick look at the blueprint for the icons. It's pretty basic. As the behavior changes, it switches the icon from one to the other. The main node is contained within the update state icon in the event graph. Part 2. Movement. Since this is a 2D game and movement is largely restrained on the x-axis, I kept it that way and I decided not to use the nav mesh. This proved to be a good decision for my purposes, but at the price of not being able to use the pre-made functions already available for the nav mesh enabled AI. But as you can see, my AI friend is simple-minded to the destruction of the player. Its default behavior is in idle. While in idle, the AI randomly picks a number within preset range in the service node here. Once it picks that number, it moves to the destination till the next number is chosen. I'm planning on upgrading this and having the AI move between 2 points. You can move around the maps to go left or right. As you can see, I am mostly using add movement input that gives the target, the world destination, and the speed or scale value. In the future, I plan on implementing an external input object for telling the AI to jump, when to jump, and how high.
That's on my to-do list, oh yeah!
Part 3. Combat. So what can this enemy do? It can shoot, it can melee, and it can search for the player and also randomly patrol the map. This is where all the range information comes into play. Essentially, when we look at the blueprint for the character AI in the event graph, here's what we'll see. In the event tick, which is continuous update, we see that it updates the AI's range in the blackboard called set range state and range finder. As you would know by now, the combat behavior for the AI is determined largely by the range from the player. Here's the blueprint look at rangefinder. Here's the preset in range for shooting. Here is the minimum, maximum range for when to move towards the player and close the gap. Here's the melee. So if the player is within minimum 56 and maximum 150, on the reverse side minimum -150 and maximum -56, then we'll see the behavior of the AI to move closer to the player. If the player moves away to a range between 150 to a maximum of 410, then the AI will spawn a projectile traveling away from the AI to the player, or the AI will shoot. This is the same for when the player is at the minimums 26 and a maximum 54. The AI will attack with melee, turning on the is melee range in the blackboard, triggering the task. As part of the combat system, here's how the damage and death mechanics work. In the event tick, here we see an update tick for the current health. This is the blueprint for the behavior tree service in its event graph. When the health is less than or equal to 0, then it activates the AI and the death sequence, and the AI will die. The sequence includes a sound and then plays a behavior tree task that stops all incoming AI inputs. I made the AI stop all incoming input once the player damages the AI. This either makes the player too overpowered or just a game mechanic I want to keep for the sake of fun gameplay. Part 4. Animation State Machine. The animation update contains all the triggers or the conditions for the current available animations. In this example, the green boxes and arrows show you the logic from activated boolean to animated sprite. In this case, it's showing shoot. Back to the animation update, it then sets the flipbook to the selected anim state within the animation state machine. In this case, it meets the condition for the shoot animation. On top of all this, you will see that there's a boolean called animating. It is there to block any other incoming animation input until the current animation is done animating. This boolean is set at the start of a condition. If true, then it keeps doing current task. If false, then it again picks appropriate animation state with their conditions. Hope this gives you some insight, and if not, then you know what to do. Give me some good old-fashioned constructive criticism. Or not. But if you do like this video, please give me a like and subscribe for more videos. Hopefully in the future. Thank you. Stay tuned.